Find the center of gravity and moment of inertia of the channel section shown in the figure. So in this problem, we want to find out the center of gravity CG and moment of inertia of the given channel section of dimension 160 mm by 100 mm of flange thickness 30 mm. So before going to the problem, we want to remember the certain equations for center of gravity and moment of inertia of the rectangular section. So we know the area of the rectangle is equal to breadth into depth, and we also know the center of gravity lies in the point of intersection of the diagonals for the rectangle. So x bar, that is distance from y axis, is equal to breadth by 2, and y bar, the distance from x axis, is equal to depth by 2. So x bar is equal to b by 2 and y bar is d by 2. So coming to the moment of inertia about the centroidal axis xx and yy, ixx equal to bd cube by 12 and iyy equal to db cube by 12. So the first step to find out the center of gravity and moment of inertia of the section, you want to fix the x and y axis for the section. So you draw a parallel line touching the base extremity and the left extremity representing the x and y axis. Then you divide the given section into known plane areas. So here rectangle is the area, so you divide horizontally into plane area 1, 2 and 3 and fix the dimensions. So coming to the center of gravity, we already know the center of gravity lies in the point of intersection of the diagonals. So here you have 3 sections. So you put a tabulation column representing the section, area and x and y with their units. So coming to the section 1, the breadth is 100 mm and the depth is 30 mm. So the area is 100 by 30, 3000 mm square. The x is the distance from y axis. Y axis, that is 100 by 2, so you'll be getting 50, and y is distance from x axis. So x axis you want to cross 3 things. One is third part, one is second part and the first part. So we are having 30 plus 100 plus 30 by 2. So you are getting 145. In the same way, we are getting for the section 2, the area is 3000 mm square and x value is 15 and y value is 80. And the third section, the area is 3000 and the x value is 50 and y value is 15. So summing up the area, you will be getting 9000 millimeter square. So coming to the centroid x bar and y bar, x bar is equal to summation ax by summation a, that is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So here a1 means area of the first section, x1 means x of the first section. So substituting, we will be getting x bar as, and y bar is equal to ay by summation a, that is a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So a is the area of the first section and y is the y value for the first section. On substituting these values, we will be getting the x bar as 38.33 and y bar as 80 mm. So the center of gravity is x bar comma y bar is 38.33 and 80 mm. So the next step is you want to locate the centroidal axis. So we already drawn this figure with the known scale. Now we want to locate the x bar and y bar. So x bar is nothing but the distance from the y axis. So from the y axis, you draw 38.33 mm line. Similarly, from the x axis, you draw 80 mm horizontal line. So it will be intersecting at a point. So this point represents the center of gravity or centroid of the plane area. So coming to the moment of inertia, we want to find out the table, the area representing the area Ixx for the Ixx and Iyy for the section 1, 2, 3 and a into x minus x bar the whole square and a into y minus y bar the whole square. So area we already know, you can fill it, and Ixx we know the formula, b d cube by 12. So the first section b is 100 and d is 30. So 100 into 30 cube by 12. Similarly, say for the first section Iyy is equal to db cube by 12. So d is 30 here and b is 100. So 30 into 100 by 12. So a into x minus x bar the whole square. So area is 3000, x is 50 for the first section and x bar is the centroidal axis, that is 38.33. So on substituting you will be getting 408.57 into 10 power 3. For the second column, the next column, we know the area for the first section is 3000 into y value for the first section is 145 and the y bar is 80. On substituting, we will be getting 12.675 into 10 power 6. So in the same way, we can do for the section 2 and 3 and find out the summation values for area, Ixx, Iyy and a into x minus x bar the whole square and a into y minus y bar the whole square and fill the table. So the final answer, that final table will be shown like this. So we know the Ixx for the total is equal to Ixx self of xx plus summation a into y minus y bar the whole square. So Ixx self is nothing but we are already calculated in the table, that is 2.95 into 10 power 6 and a into y minus y bar the whole square, that is 25.35 into 10 power 6. We will be getting 28.3 into 10 power 6 power 4. Similarly for Iyy, summation Iyy plus summation a into x minus x bar the whole square. So Iyy, the summation table is, that is 5.225 into 10 power 6 plus a into x minus x bar the whole square sum will be 2.45 into 10 power 6. On adding, we will be getting 7.675 into 10 power 6 power 4. So the final answer should be, we want to represent diagrammatically, we want to locate the centroidal axis CG, x bar and y bar, representing the answers, and the moment of inertia and about x and y axis is 28.3 into 10 power 6 millimeter power 4 and 7.675 into 10 power 6 power 4.